Hi guys, today we're going to take a look at another way to solve quadratic word problems, and that's by using a graphing utility. The one we're going to be using is Desmos, D-E-S-M-O-S, and you can either go to the website, Desmos.com, or you can download the app for your iPhone or Android. I'm going to be using the website, and we're going to take a look at 523, question number 3. It talks about hitting a golf ball into the air, and it gives us an equation, and part A says, what's the maximum height reached by the golf ball? And here's the way you'd use Desmos to figure it out. In this section is where you type in the equation. So I'm going to click over here. Desmos doesn't use H and T, it uses X and Y. So for the equation, I'm going to type in Y equals 32X minus 5X, and here's the squared button. And as soon as I type that in, you can see that it graphs the equation over here. I'm going to zoom out using my mouse wheel. If you're using a tablet or phone, you can pinch to zoom. I'm going to scroll up to take a look at the top of it. And there's my vertex. That's how I tell when it hits the highest point and how high it goes. If I weren't using a graphing utility, I'd have to use negative b over 2a for this. But since I'm using a graphing utility, all I have to do is come up to the top and click on it. And it's going to give me the coordinates right there of the vertex. That tells me that after 3.2 seconds, it's 51.2 meters high, which is its maximum height. So 3a is 51.2 meters. Okay, let me see. Question B says, when was the golf ball 25 meters above the ground? So I've got to get the 25 in there. Now, if I were solving this algebraically, I would plug 25 in for h, put it in standard form, and then use the quadratic formula. Using the graphing utility, I'm going to come over here. This lets us type in another equation. I'm going to click here. And the second equation I'm going to type in is y equals 25. That's the 25 is because that's the question, the height that it's asking the question about. And when I do that, you can see that it's drawn in a blue line here, a horizontal blue line, which is y equals at 25. And I can see these 2 points where the graph of the golf ball is equal to 25. Okay, and to find the coordinates, I'm just going to click on it. And same thing over here. And it's told me the 2 times the ball is 25 meters high. One is 0.91. So I'll type that in, 0.91. And the other time it's 25 meters high is 5.49. 5.49 seconds. Okay, question C says, how long was the ball in the air? So I'm going to come down to where it hits the ground, which is here. And I'm just going to hold the mouse over that point as close as I can get to it and click. And it gives me the coordinates, 6.4 and 0, which means that after 6.4 seconds, the height is 0, which means that it was on the ground. So it hit the ground at 6.4 seconds. If I were doing this algebraically, I would have plugged in 0 for h and then used the quadratic formula. And part D says the number 32 represents the initial speed, and it says how would it change if it were 34 instead? Well, let's take a look at that. I'm going to come over here and delete this, change this y equals 25, and I'm going to type in 34x minus 5x squared. So the red curve is the original path of the golf ball at 32 meters per second, and the blue one is the new path of the golf ball at 34 meters per second. So let's see what would happen to it by looking at the graph. Okay, you can see that it goes higher when you hit it harder, when you hit it faster, and it also stays in the air longer. And we can actually see how much longer. Originally it stayed in at 6.4 seconds, and when we hit it faster, it stays in the air 6.8 seconds. So that's how to solve quadratic word problems using a graphing utility. That's it for today.